Hello, and welcome to IBM Developer. I'm your host, Luke Shantz. In this edition of our Origin Story interview series, I have the pleasure to bring you a conversation with Dan Walsh. Dan is a senior distinguished engineer at Red Hat and leads the container engineering team. Hello, Dan. Thanks for taking the time to connect.
Great to meet you, and great to have a talk.
Dan, could you give a brief introduction to yourself so our listeners have a little context?
I've been in the tech field for about 35 years. I've been working for Red Hat for the last 19 years. Mainly, most of my career has been on around security, and basically security products more than necessarily security. So I'm a developer, and for many years at Red Hat, I worked on SELinux, security enhanced Linux, and for probably the past 10 years, I've been working on container technology, and basically everything to do with containers at the operating system level. So that's what I do.
And I noticed that you're giving the opening keynote at the upcoming Cloud Native Security Conference that IBM's putting on. What's your talk about?
It's actually about container security. People that have followed my career and stuff, I usually try to explain stuff in the form of coloring books. So I talk about technology and try to sort of relate it to other things. So this talk is basically about Goldilocks and the Three Bears, and how container security is really about Goldilocks at this point. And I talk about if you remember that Goldilocks story, Papa Bear is always too hard and Mama Bear is always too soft, and Goldilocks is sort of the medium point. And I'm talking about how in container security, we're really going for Goldilocks because we want to be able to work with generalized workloads. So if you get too close to Papa Bear, basically everything starts to blow up and people can't get their workloads done. And if you move towards Mama Bear, then what's the purpose if you're just going to a lot of people just turn off security. So to start with, that is the key parts of the talk. But then what I've been investigating is how we can move a little closer to Papa Bear. And I also put the assumption in that users only do two things. They either run their jobs or they turn off all security. And so the overall assumption I always have is that no users ever increase security. They're always, this doesn't work. Let me turn the firewall off. Let me turn off SELinux. Let me turn off, this rule. Oh, now it works. Okay, I'm good to go. So in the security world, we're always trying to get as much security as possible without users turning everything off. That's really what the talk is about, and generally how I'm trying to address my team right now. How do we get a little bit more secure than we've been in the past?
That's interesting. And you mentioned you've been working on container space for 10 years. So you've really, from day one, it sounds like, been sort of on that, because I mean, it's not that old of space.
I always, when I give my talks, a lot of generalized talks, I usually, if you look at containers are, in Linux world, are around three different key components. There's container separation on resource restraints. That's a thing called C groups. That was actually introduced back in the Linux kernel around 2008 timeframe. I usually base things on when it becomes enterprise quality. So RHEL 6 came out in 2008. The other area containers is around what's called namespaces, but that gives you a virtualization feel. And the first namespace actually showed up in around 2005, 2006 timeframe. And we worked on that. That was called the mount namespace. And then if you look at the third area, so you have C groups for resource constraints, resource controls on processes. You have namespaces for virtualization effect on them, and then you have security, right? So you want to add some kind of security to make sure that the processes can't easily break out of the first two confinements. But if you look at security, it goes all the way back to the beginning of Unix, right? So things like, just running processes with different UIDs and stuff like that. And then you get up to SELinux, which came about in 2001 timeframe, and SecComp, which a few years later, and additional namespaces, things like that. So this everything was sort of been evolving in the whole life of Linux. And then Docker came along in 2013 timeframe, and what Docker really did is made using these concepts easy. And the real breakthrough that Docker did at that time was they basically figured out a way to bundle software into a new distribution format. And they called it, at that time, they called it a Docker image. I like to call it a container image. But basically, it's a way to take a whole bunch of software, the application you're working on, plus all the underlying libraries and tools, and you bundle those up into a really just a tarball, and take the tarball and some JSON that describes what's in the tarball, put that together, store it at a website, and Docker called that a container image, and then the website called it a container registry. And then they built tooling to just pull these software bundles to a host, set up all the container technology, and start running them. And that's really when people started to look at containers as being, and a real thing. But really, the underlying technology all goes back to starting really in around 2000, 2001. And if you look at, set different stages, namespaces and control groups and things like that coming on bound. And I've been working on the technology pretty much from the beginning. So that's a little bit of history.
Well, and you mentioned usually getting sort of interested or really into it when it's enterprise ready. So I just want to mention that or ask about, because you are known as, I've seen you're known as Mr. SELinux.
Right.
So at what point I'm just curious, just to now I'm for my own sort of understanding of the landscape. At what point did Linux become enterprise ready? Was that SELinux and then it evolved into RHEL and
no, I actually say it was enterprise ready before that. So, I mean, I started at Red Hat when Red Hat was still basically shipping software at Best Buy. So it was just basically a box software package that you would go to Best Buy and buy, at that time, Red Hat Linux, 6 or Red Hat Linux 7. But at that point in history, we were just shipping software every 6 months, right? So and all of a sudden you had people liking Linux, and they were bringing it into enterprises. And, these enterprises could be great big banks or government and things like that. And they were starting to run actual build servers on top of actually Red Hat Linux at the time. But if you installed a web service or something like that on top of Red Hat Linux, and then 6 months later, you would get a new box set or a new CD, and you'd have to upgrade. And then 6 months later, you'd have to upgrade. And 6 months later, and there was so it was a constant churn in Linux at that point. And up to this day, there's still a churn, right? Like Fedora and Ubuntu, they're always releasing new versions. So what made Linux enterprise ready at the time was more that Red Hat agreed to stop the churn. So what enterprises wanted was basically to have the Linux operating system, they'd be able to install it and then have it good for 2 years. And the only thing that they would get updates for would be security fixes, right? And so making something enterprise ready really means that you stop the speed of innovation. You freeze the speed of innovation, and then you just allow backporting of fixes. It also involved someone looking more deeply into security stuff. So when I joined Red Hat was before that happened, but really at the foreground of that in the first year. Matter of fact, I think AS2.1, which was the first enterprise Red Hat Enterprise Linux 2.1 is what we called it, came out about around 2002 timeframe, and that really sort of kicked off this slow-moving operating system that would be more stable. Simultaneously with that, the United States government at the National Security Agency was developing they felt that Linux was too insecure. Actually, all operating systems were too secure and too insecure. And what they wanted was some mechanism, new mechanism for adding security to operating systems. And they had developed something called Security Enhanced Linux, or SELinux at the time. And they were having a hard time getting upstream communities to adopt it or get distributions to adopt it. So they came to Red Hat and basically said they wanted to work with us. They wanted to fund us making SELinux and getting it into the upstream Linux kernel and getting it into a distribution. And at the time we said, sure, we'd be interested in doing it because it tied up with the enterprise stuff. But the problem we also wanted, we didn't want the NSA to just fund the original development and then disappear from the planet. And so we had an agreement with the NSA, National Security Agency, that they would continue to work and develop it over the years. And so now we're 18 years later, and they still fund development. Matter of fact, all Android phones in the world right now are running with SELinux. They call it SE Android, but it's basically the same thing. So the National Security Agency has still been involved in the whole development process of SELinux. And that's sort of the history. At the time, I had just started at Red Hat when SELinux was happening, and they knew I had a security background, so I was assigned to work on SELinux. And over the years, SELinux now has become one of the fundamental ways that we secure virtual machines, as well as securing containers on the system. So I still work somewhat in SELinux, but more towards containers at this point. So that's a little history.
That's a fascinating history. And two thoughts come to mind. First thought is my first experiences with Linux are exactly like you're saying. In the late 90s, early 2000s, can't remember the exact year, but going to the bookstore and buying the book and the bundle of the CDs and installing it on the old PC. Totally my first experience. And the other thing which you might find amusing is last year at OSCON, I met the NSA community team because they had a booth there,
right.
And they were pre-cleared. They were promoting pre-cleared for a conversation, and they came on the podcast. So I have an episode with the NSA community team, and it ties into this history you mentioned where, fast forward 18 years to today, and I think they have 30 or 40 different open source projects that they've released. And right. they were promoting Ghidra, which is a decompiler for like reverse engineering software.
Yeah.
Although they were quick to point out, don't use it for reverse engineering proprietary software.
Okay, yeah.
So yeah, that's great. And I think this segues back because part of really the point of this series is to give a little bit of a glimpse inside the black box of what the enterprise is and show the developer community what a career inside of enterprise looks like. So if we rewind back to your origin story, the very beginning, what was the impetus that sparked you on this path? And I mean the very beginning. Was it math class or the ham radio or the...
So I'm so old that when I graduated high school, I'd never touched a computer in my life. So it was not, I grew up in an era where computers filled the room. So, I graduated college in 1982, the first, and at the time, growing up in the 60s, the coolest people in the world were the astronauts. Well, in my worldview, the coolest people in the world were wearing white shirts with little tiny black ties, the guys in the control room. So if you had asked, me at 13 or 14 years old, what I wanted to do, I wanted to be in Houston Space Control and working for NASA. And so that translated in my brain, computers were becoming this interesting thing. So I said, I want to be a computer guy. And I was really good at mathematics. So I ended up going to a college and majoring in mathematics because I didn't have a computer science major. And there was a technical school down the street. So I went to Holy Cross College in Worcester, Massachusetts, and it was Worcester Polytech. So I would go to school at Holy Cross and also take courses at Worcester Polytech. And the first course I ever took was actually in punch cards. So we actually, back in the day, you would have a deck of punch cards, and you would go to the lab and you'd give it to you'd file them in, and they would process all your cards. And then 2 or 3 hours later, you get the compile back and tell you whether or not your program worked or didn't work. And so that was my first experience in them. When I graduated college, with a mathematics degree, I went to work for a small company doing software, and then eventually I went to Digital Equipment Corporation. And when I got into Digital Equipment Corporation, I worked a couple of years, and finally I started working. So I was just a general programmer at that point, and I joined a group working on a thing called DEC Athena. And the history of that is it came out of MIT. MIT Athena project, and that might not mean much to young people, but they probably have heard of things like Kerberos and X Windows, and some of those were two of the big projects that came out of MIT Athena. And Digital Equipment Corporation at the time was trying to productize that, and I started working on Athena, and a lot of that stuff was getting it working on top of Unix platforms at the time. Roll forward a few years, another fairly famous historical mark, I went from the Athena project to work on Alta Vista project. So Alta Vista was the first search engine in the world, but the Alta Vista group didn't just do search, they also did security products. So I was working on the first firewall, and it was actually the first firewall at the White House. And I also worked on VPN projects. At that time we called them tunnels, but basically tunneling traffic over the brand new internet and figuring out how to do virtual private networks. So I did that for many years. Digital Equipment started to fold up, and Digital got bought by Compaq, and Alta Vista never spun out of Digital, so Alta Vista could have been the original Google, but it didn't happen. And then I left there, went to work for a company that did. The company was called Hacker Shield, and they basically tried to use hacker tools, so tools that you would attack a network with, and figure out if your network has vulnerabilities, and then help you fix the vulnerability. So it's really a vulnerability scanner by using attacking tools. Anyways, that company became another company called BindView. And I worked all this time. I was working for this guy named Paul Cormier, who now is the CEO of Red Hat. So I've worked for Paul Cormier for 30 years now. And he left. He actually at that time left. He was working for the BindView company that I was working for. He left and joined Red Hat. And 6 months later, BindView basically, this was during the .com bust, folded up, and Paul called me on a Friday and said, "Hey, you want to work for Red Hat on Monday?" And I said, "Sure, I'll come over and work for Red Hat." And I've been at Red Hat for the last 19 years, and that's my history. And I sort of fell into security products, and after you've been doing security products for a while, you sort of learn the lingo and everything else. So it wasn't like I graduated and I loved computer security. It's just that's where I ended up with, and now I'm well known for working on computer security 30 years later. So that's my history.
That is fascinating, and it really have followed the arc of the technology, at the pulse of it. Like you mentioned, like the early firewall at the White House, which is fascinating.
Yeah, so sometimes it's sort of like you feel like you're Forrest Gump, and it's like you just happen to be in places where things were happening over the years, so it's been interesting. It's been an interesting career.
At what point, or can you give us insight into the transition that happened with Openshift going from like a sort of platform as a service into this Kubernetes-based container platform as a service?
Well, I can give you a little extensive history on that, because I've been in Openshift since the beginning. So originally, Openshift was Red Hat formed Openshift back in 2008, 2009 timeframe, and our main goal was to get developers to develop code on top of RHEL, so Red Hat Enterprise Linux 6 at the time. And so when they started developing Openshift, they were looking at, as a PaaS server, basically to allow developers to get onto a platform, develop code, don't have to, we couldn't charge them anything because developers don't pay for software. And so they were coming on there and they were developing code. And I think at the height of Openshift version 1 or Openshift version 2, they got up to well over 1 million users of it. well, if you have a million users working on web services and things like that, we needed to secure them. So I was, one of the chief guys figuring out how to use things like SELinux to make sure that all the developers on top of OpenShift did not interfere with each other, and that you have some bad people. When you give people computer resources for free, you tend to attract some unsavory characters, we'll say that. And so we wanted to make sure that we controlled and locked down the systems as best we could. And over the years, we did a very good job with it. So if you think about it, so we were very successful at getting people to working on developing software for RHEL, but it was tied to this web server, web services and things like that. And there was no, what we wanted to do was to get them to be able to develop software that they could then take and figure out how to run it on other RHEL systems. So to help sell into the RHEL, the greater Red Hat enterprise stuff. And what we ended up having to do is you'd have to sell OpenShift into these environments in order to they'd have to run these web services in order to run this software. So it was tied together. So that was happening in 2010, 2011, 2012 timeframe. And that was about the time we were coming out with Red Hat Enterprise Linux 7. And Red Hat, so I was working on container technology at the time, and it was very different container technology that Docker ended up with. Because we at that time were viewing the world as taking an operating system and then dividing it into containers. So basically sharing /user around with 50 or 100 containers. So it was sort of what we were doing with OpenShift, but now looking at could we package software and somehow get it to use stuff in /user, but basically isolate it from each other. And so we were working on that, getting all ready to release it for RHEL 7. And one of the great things about Red Hat over the years was that we realized that something was happening in the open source world that was really starting to explode in importance, and that was Docker. And so about 6 months before RHEL 7 is going to ship, we had lots of people running to me and saying, hey, do you ever look at this thing called Docker? And I said, at that point, I didn't even know about it. And 6 or 9 months later, we had shifted the entire platform to be based on top of Docker technologies. So that meant OpenShift was shifting to Docker. So at that point, again, what Docker brought to the platform was an easy way for us to package up software that the developers were developing and then be able to distribute them so other people could run them anywhere. And now you wouldn't have to run a huge web service to run each one of these containers, each one of the pieces of software on top of a Red Hat Enterprise Linux system. You'd be able to just have, say, a Docker daemon running, a Docker clients running, and you could just run them anywhere. So that was back in 2013. About 2014, 2015, everybody was realizing that Docker worked real well at a node level, but didn't work real well if you went to multiple nodes. So once you got to, the enterprise level was, we wanted to run 100. And you write an application, you want to run 100 different servers and have it fail over and do that stuff. So the first DockerCon, and Red Hat was working on a thing called we called it GearD. It was based on the original OpenShift. And that was our way of orchestrating, right? So our own language. And we went to DockerCon, and probably half the talks at DockerCon were talking about different ways of orchestrating. There was Mesosphere, there was Docker Swarm was in its infancy. We were selling GearD, and Google came in and basically with Kubernetes. And yet again, the powers at Red Hat realized that Kubernetes was coming off as the most popular way of doing this. And so we decided to switch away from what we were working on. We weren't going to win the hearts and minds, so we might as well dump what we were doing, and we shifted to Kubernetes at that point. And Red Hat quickly became the second largest contributor to the Kubernetes community, and so that's how it evolved, right? So we've pivoted many times over the years, and again, that's the beauty of open source software, is we get to watch what all the community is, figure out what's good, what's bad, what's getting community interest, what everybody's is going to be willing to work on, and then the goal of Red Hat is to figure out how to productize that. Right. A lot of times I tell people that Red Hat does the sucky part of Linux, or the sucky part of Kubernetes, so the sucky. So the interesting thing in the open source world is everybody wants to do the next sexy thing, right? The next cool item. You can always find lots and lots of people to do that. But when you get to enterprises, what enterprises care about is, I need this to run, and I need it to run for the next 3 years, and I don't want any new feature coming in that's going to break it running for the next 3 years. And what Red Hat's always been really good at is figuring out how we can get things stable. So really, if you look at our history with Openshift, once we got to Kubernetes, is all about how do we make Kubernetes stable. Kubernetes changes every 3 months. And, so there's this constant, there's a huge push and upgrades and things like that. And how do we get upgrades to be smooth? How do we get, the whole container world to be, work well? And, in order to do that, we've, Openshift has done things like, we purchased CoreOS. So we originally built a thing called, what we call Project Atomic, which was a stable operating system for running containers. CoreOS was a competitor, and Red Hat ended up buying CoreOS, and we combined the technologies together in order to build a new operating system for containers that would be stable, and we could work with Kubernetes. So now if you look at the Kubernetes OpenShift version for 4.5, 4.4 to 4.5, 4.6, it's tied to CoreOS. And again, that's all about stability. So I like to tell people, when you look at running containers in the world, right, the Kubernetes world, you have the operating system, which is moving at one rate. Then you have what I call container engines or container runtimes. And these are things like Docker and Cryo and Containerd, these new container engines. They all have a release schedule. And then you have Kubernetes, which has its own release schedule. So if up till OpenShift 3 timeframe with Kubernetes, all three of these things were moving at their own rates. So the test matrix was huge, and I call it Jello, right? You'd have the bottom layer moving, the operating system moving, you'd have the runtime, the container engines moving, and then you have Kubernetes moving, and you have the whole thing shifting underneath it. And of course, that causes huge stability problems. And with us, with Kubernetes, we want to get it running on 10,000 nodes, right? We want to get to huge numbers of containers, hundreds of thousands of containers. And what we really needed was a way to lock down all those modes so we could test one entity at a time. And so now if you look at OpenShift 4, we have what we call Relic CoreOS. And what's in there is we baked in the operating system, we baked in the container engine, and we baked in the level of Kubernetes. So there is no 8.2, we have RHEL 8.2, RHEL 8.3, but there's just a RHEL CoreOS that works on this version of OpenShift. And that might have RHEL 8 underneath it, and it might have a certain level of container engines underneath it and a certain level of Kubernetes, but the whole bundle is tested together, and therefore we can get to the stability level that a enterprise wants. And anybody else that's built, if you go and compete against regular Kubernetes, you have sort of the Jello mode, right? So what operating system you're running on, or what version of container engines and what version of Kubernetes, and those are constantly shifting. And so it just becomes something that really can't be tested as a unit, and doesn't give you the stability. So I'll get off my high horse, but that's a really cool thing about containerized operating systems like RHEL CoreOS.
Well, thank you. That was an amazing explanation, and I think it gave a lot of insight into, I like the term, it's like how the sausage is made.
Right.
And it's because, I think there's a lot of popular sort of hype around open source, and it is amazing opportunities for developers to, get involved and follow their passion, but also get recognized and build a path for themselves. But then, like you're saying, there's constant versions and updates, and now you build something and the project goes in another direction. Yeah, it's fascinating to hear. It's very much an emergent process.
Right. I like to say that, in the open source world, choice is the greatest thing ever, right? Everybody has choice. You can constantly pivot and choose. But when you get to enterprise customers, what they want is they want an intelligent unit to come in and choose for them, right? It's sort of like, I don't know if you ever go to a restaurant and they have a menu with 4,000 items on it and you can't choose anything. But then if you go to a menu with 6 items on it, it's really easy to choose. And so you hope that the restaurant made the right 6 choices for you. And really what Red Hat is bringing to this is we're sort of making opinionated, right? We're learning and studying, always growing on how to do Kubernetes best. And what we will do is pick the proper way, the way we believe is the best way to run Kubernetes. So we believe to be the best version of container engines, or we believe to be the best operating system, and then join them all together. So really what you want to do in the enterprise world is you want to pay someone to make smart choices for you and to provide you the stability and the container, the security and the trustworthiness, things like that. To the platforms.
So folks that are already in, enterprise world are probably familiar with this dynamic, but maybe you could comment on this a little bit. Let's say we harken back to your early days in working. I'm sure everything was probably very proprietary, right? Very secret. But now you have this world where, in one sense, all of these companies are collaborating on the underlying plumbing and sharing, but then they're competing also using those same technologies. So it's a really interesting dynamic that there's collaboration, but then also competition with, like you're saying, making it usable for the customer.
Right. I mean, my career has gone, this pendulum has swung back and forth. So if you look back to the early days of Unix, right, everything was shareable at the time. I'm talking back in the 60s and 70s. Richard Stallman started introducing, glibc, the first glibcs and Emacs and tools like that, and that was all shareable code or public domain code. And then Microsoft came along and basically figured out how to make money off it, and then closed up everything, and Apple and stuff. So when the open source revolution happened, it was sort of an ongoing experiment. But whenever I look at software, it's always, every vendor is trying to get, to control their customers, right? Everybody wants to own their customers, and one of the best ways to do that is to either own their data or to own the software that they're going to run on. What Red Hat has always been about is doing it the open source way, which is the best way for us to own our customers is to do a good job for them, and that puts a constant stress on us. But we have to constantly perform. Otherwise, customers can just go and use CentOS or just go and use the open source projects to replace us. And so that's always been a great goal of Red Hat. And I actually, since this is a little bit for IBM has helped fund a lot of this, going way back to when they first gave the $1 billion to Linux back in the early 2000s. So that's the way we've always worked, and I've always been very against closed source software, for obvious reasons. Now what I see is a lot of vendors trying to use open source software to lock in companies to their ways of doing it. And I talk about cloud vendors all the time. And you have the Amazon and the three big, the Amazon and Microsoft and Google are all looking to somehow lock you into their, they might be using open source software, but what they want you to do is lock you into their proprietary protocols. And I call this, again, I always use cartoon analogies, but Hansel and Gretel, you go to the witch's house and you're all right, but you see the sweet candy that's sitting there, and you start eating the candy, and next thing you know, you're in a cage. And that's the way I like to talk about Amazon, is all about, you can come and use our RHEL instances or our operating systems instances, but we have this really cool, file system layer, S3, and, you can start using some of that. Or we have these really cool services that will provide you can start using that. And all of a sudden, 6 months, year later, your software is based on top of Amazon's protocols. And, Microsoft Azure comes along and says, I can give you 10% discount if you move to here, and all of a sudden you realize that you can't move your data out because you built your software on proprietary protocol, so they've locked you in. So really what the beauty of OpenShift is all about preventing that type of lock-in. Our goal is to provide enough of the services, and you can build on top of our services, and you should be able to run your workloads on top of Amazon, on top of Azure, on top of Google, or even top of IBM's cloud, or on top of VMware, or on top of your local physical hardwares. And really what you want is that flexibility, because in my opinion, when you go into the cloud world, a lot of companies realize that they can go into the cloud world and get services up and running really quickly. But if those services become really, really popular, their bill, right, their rental bill is just going to go up and up and up. And at a certain point, it becomes more sensible to build inside, right, to build your own data centers and try to get your data out of the cloud and into your own data centers. And it becomes impossible if you've done the Hansel and Gretel candy stuff. You were in a cage, you can't get out unless you use something like OpenShift and truly open source software. So even if you can use OpenShift without using Red Hat, but if you want to have a supported platform from a company that can help you prevent that lock-in so that you can move around. My dream is at some point you're sitting in an OpenShift console and you're running 75% of your workload inside of Amazon, 25% locally, and Microsoft sales rep calls you up and says, if you move 50% of your workload to us, we will save you 5% on cost. And all you do is you press a button on your console, and all of a sudden 50% of your workload shifted over to Microsoft, and seamlessly, and you're suddenly saving money. And you could get competition levels at the cloud vendors to make them compete for, instead of getting lock-in, you basically have this, you're able to offer them the ability to compete. The other thing is, if you think about it, OpenShift is all about running containerized workloads on all these different areas, and it competes against cloud instances of Kubernetes. But if I'm Amazon cloud, I'm really trying to drive you to get your workloads off of your own data centers into their cloud, and so I can lock you in and make more money. And in our world, we don't care. OpenShift doesn't really care where you run your workloads, right? It's just you run your workloads in the places that make sense, not trying to always suck you into the cloud instance. So it's a different way of looking at it. But I mean, the beauty of open source is always has prevented lock-in in the past, right? So you didn't have to run your stuff all on an HP, certain HPs or back in the day, digital VAXs, or on top of IBM's hardware, right? You could pick and choose whoever gave you the best deal for your hardware, and then just run your software on it. So it became competitive. Now in the container world, we want to make sure that we have the same type of competitiveness in the cloud world. So where you want to run your environments is easily flexible to be able to move around the environment.
That really makes sense and sort of fills out or fleshes out an ideal model of how the hybrid multi-cloud would work. That you would be able to actually do that, because like you said, if you read just the first line of the brochure, oh, it's open source, I could move this anywhere. But when you dig a little deeper, sometimes that's not so much the case in the fine print, or the devil in the details, so to speak. I think you did a fantastic job there of laying out how does OpenShift fit into this hybrid multi-cloud world to give you the most flexibility and the best performance.
Right. Another expression. Amazon loves to show this video of the Amazon truck. They'll send you a 16-wheeler to your office with all sorts of computer power on it, and will take all your data and you put it into this truck, and then the truck drives off to Amazon data centers and takes your data, and boom, your data is inside the cloud and you are up and running. And that sounds like a wonderful story, but I always tell people that truck doesn't have reverse. Right, that truck never comes back. Yeah, so if you get in there and you don't like what you got, you can't get out. It's just something people need to think about when they're taking advantage of these services.
So let me ask you this. Is there anything I didn't ask you that I should have, or any closing thoughts you might have for our developer audience?
Developers are the ones developing the applications that are going to run inside your container environment. And what I want application developers to think about is, what are the security needs of my application? Because if I go Goldilocks, I'm basically giving every container has this level of security, needs this level of security to run. And that security has to cover all possible use cases. If you build a container image and you could specify something in the container image that says, my image doesn't need as much, you know, um, security as the general purpose, I can actually run with a lot tighter security, and they could put that information into the container image. Then our container engines could read that data and say, well, instead of running with this fairly loose policy, I'll run with a tighter policy. And so that's sort of what I've been pushing. That's what I'll be pushing for the next year, is trying to get developers to think a little bit about, how much, what security requirements do I have for my application? And these are things like, I don't want to get too technical because I don't know how technical your audience is, but there's things called Linux capabilities, which are sort of subsections of the power of root. And my application might only need set UID and set GID, but containers by default get 14 capabilities. Mine might only need 2 of those 14. So if I could specify that in the image, I could run it more securely. Another thing would be seccomp filters, and we're building tools to help the developers understand that and be able to generate, this is really the only security my application needs, and then that would allow us to run the individual applications much more securely than we do at this point. So, but anyways, this is a good general talk. Thanks for having me.
Thank you very much, Dan. I really appreciate you being on the podcast/video.